there to distribute 7 cookies to 4 kids so that each kid gets at least 1 cookie. What can you say about the corresponding stars and bars charts? Here I have 10 possible positions. So we want to give 7 cookies to 4 kids. The charts must start and end with at least 1 star. Now, why is that? Well, so that kids A and D get at least 1 cookie. And also, no 2 bars can be adjacent. There are 3 bars total that we need to put here. I can't put the 2 bars here because that would mean that one of the kids is entirely skipped and given no cookies. Each kid must get at least 1 cookie. So we have to make sure that no 2 bars can be adjacent. One way to assure this is to place bars only in the spaces between the stars. So with 7 stars, real quick, I'm going to show you real quick what I mean by this, by drawing it. So with 7 stars, there are 6 spots between the stars that we can choose where these bars go. Here, or here, or here, or here, or here, or here. We can't put the bars here because, again, we have to start and end with a bar. Likewise, we can't put a bar there. So we only have 6 possible locations to where these 3 bars go. So again, we must choose 3 of the 6 spots to fill with bars. Thus, there are 6 choose 3 ways to distribute 7 cookies to 4 kids, giving at least 1 cookie to each kid. Now, another more general problem another general way to approach this modified problem is to first give each kid 1 cookie. Now, the remaining 3 cookies can be distributed to the 4 kids without restrictions. So we have 3 stars and 3 bars for a total of 6 symbols, 3 of which must be bars, which gives you 6 choose 3. So again, we see that there are 6 choose 3 ways to distribute the cookies. Now, stars and bars can be used in counting problems other than kids and cookies. Let's do another example together. This example says, how many integer solutions are there to the equation x1 plus x2 plus x3 plus x4 plus x5 equals 13? Now, an integer solution to an equation is a solution which the unknowns must have an integer value. Now, we're going to have 3 parts to this question. The first part is where each of the variables, xi's, have to be at least 0 for each xi. So let's talk about how to do this. We need integer solutions to x1 plus x2 plus x3 plus x4 plus x5 equals 13, where all of the xi's must be at least 0. Now, we can actually technically say that this is not a kids and cookies problem, but it is a kids and cookies problem. In this case, this is like having 13 cookies that we're going to give to 5 kids. We can give all 13 cookies to the first kid and 0 cookies to the others, or we can give 10 cookies to the second kid and 3 cookies to the 4th kid. There are many solutions to this, and we want to count all the ways that we can do this. But we know how to give cookies to kids. Now, let me write down real quick what we've discovered about part 1. And keep in mind, we're only doing part 1 right now. We have 13 cookies, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 5 kids, A, B, C, D, and E. And we're trying to give cookies to kids. Now we know how to give cookies to kids. In this case, this is just a stars and bars problem. Now, of course, we're in the section where we're talking about stars and bars, so you can expect to see that we're going to be using stars and bars to solve this problem. Now, how can we translate this problem into stars and bars? We have 13 cookies and 5 kids. So how many stars and bars do we need? Well, be careful here. We need 13 stars, but only 4 bars because we're giving cookies to the first kid, then we switch to the second kid, then we switch to the third kid, then we switch to the fourth kid, and finally we switch to the 5th kid. There are a total of 4 switches as we distribute cookies. So there are a total of 13 stars and 4 bars. Now, real quick, I'm going to represent this with some underlines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so there are 17 total places where we can put our 13 stars and 4 bars. Now, if you want to think of it this way, we're going to choose first where our bars go, and then the rest are going to be cookies. So we have 17 total locations to put our 4 bars. And so that means there are a total of 17 choose 4 ways of putting our 4 bars. This is also the same, though, as 17 choose 13 if you want to place the cookies, find all the different ways you can place 13 cookies, and then put the 4 bars in the leftover positions. So 17 choose 4 is the solution to the first problem. Now the second problem. In this case, we must have that each kid gets at least 1 cookie, or that each of the integers must be they must be positive. Well, how do we figure this one out? Well, there's a way of doing this. If each kid has at least 1 cookie, what we can do with our 13 cookies is we can give each kid a cookie and then count how we distribute the rest. So we could give each kid a cookie. So I'm going to put A, B, C, D, E here. These are our kids. And I'm going to give 1 cookie to each kid so that each kid has at least 1 cookie. Now, how many cookies do we have left? Well, there were a total of 13 cookies, and we just gave 1 to each kid. So now we have 8 cookies. And we need to distribute these 8 cookies to 5 kids. And that's really what we're counting here. We're counting how many ways can we give 8 cookies to 5 kids, and then just give each kid a cookie to make sure that each kid gets at least 1 cookie. This actually counts all the different possibilities here. And so in this case, we have not 13 stars, but we have 8 stars and 4 bars. So we have 8 of these and 4 bars. How many ways are there? How can we arrange 8 stars and 4 bars? Well, if there's 8 stars and 4 bars, that's a total of 12 objects. So there are 12 objects total, and we need to choose 4 of those objects, which 4 of those objects to be bars, and the rest can be stars. Or we can choose 8 stars, and then the rest have to be bars. So the answer here is either 12 choose 8 or 12 choose 4. They're the same answers. Now, let's do 3. 3 is a little bit different, but not too different than number 2. Now, with problem 3, each kid must have at least 2 cookies. Well, if they have to have at least 2 cookies, let's give 2 cookies to each kid and then find ways of distributing the leftover cookies. So in this scenario, I'm going to give 2 cookies to each kid right off the bat. How many cookies are left? Well, I just gave away 10 cookies. Now I have 3 more cookies to distribute. I have 3 cookies, or in this case, 3 stars, and a total of 4 bars. How many different ways can we do that? Well, in that case, it's 7 choose 3 or 7 choose 4, depending on what you want to choose. You want to choose where the stars go, or do you want to choose where the bars go? Anyways, thanks everyone, and I'll see you in the next video.